guarded stuff? Alright, one more. And we'll be done. What does this one say, Robert? Will you read it to us?
Find the equation of the tangent line to the graph. F of x is equal to 2x plus sine of x plus 1 on the interval 0 to 5 at the point which is guaranteed by the mean value theorem.
Okay, so what are we ultimately looking for here? Equation of the tangent line. What do I need to write that? I need the sot and the pot. So I need the slope of the tangent line and the point of the tangent line. Okay. Specifically, where is the point of the tangent line going to be? What does it say? Is it 0 pi? No, this is an interval. Those are x values. That's not a point. Where would it be at? At the point that is guaranteed by the mean value theorem. Oh. So that means we've got to find that c value, right? So the point is actually going to be c f of c. So before I can find it, I need to find out that c value guaranteed by the mean value theorem. So do I need to show that mean value theorem guarantees a value?
Yes.
Or can I just jump straight to finding that value? What do you think?
How would you know you didn't get
Can we jump straight to find it already? Because they're telling you which is guaranteed by the mean value theorem. So are they already telling me that it's guaranteed?
Then you have to guarantee
Yes.
it by showing the
So let's write that down. Already said it was guaranteed. Gar. G-U-A, right?
It's the top of you.
Guaranteed. So already said it was guaranteed, so what? So find it. Okay? You don't have to write that, you can just jump straight to finding
No,
it.
no.
I don't write it.
The iron,
I'm writing it so you can understand why we didn't show that MBT
what?
applied.
I don't know what the oil is.
Good? Alright. What does MBT say?
Oh, mine's horizon.
IROC equals A-rock.
Horizon.
Okay? What do you think we need to find?
What are you talking about?
We need to find f prime of c and the average rate of change, right?
Pretty
So
good.
what's f prime of c gonna be?
Pretty good. Like,
Okay, let me write it up.
the guy has enough. Nice stuff.
We know that the derivative at c should equal the average rate of change from a to b. Alright, so let's find f prime of c. What's f prime of c gonna be? What's the derivative? Two. So that's cosine x?
Yeah.
Okay. So what would f prime of c be? Two.
You know what?
Plus
Cosine of C.
cosine of c. Equals. What do we get on the other side?
F of times. You just have to figure it out.
F of pi
The same.
minus f of 0 over pi minus 0. Okay, so what's f of pi? Gotta figure that out, right?
Yup. Pi.
Yeah. So let's figure out f of pi. So that's gonna be 2 times pi
So 2 pi plus 1.
plus sine of pi plus 1. What's sine of pi? 0, so that gives us 2 pi plus 1. We also need f of 0. So that's going to be 2 times 0 plus sine of 0 plus 1.
So 1.
1? Sine of 0 is 0? Alright, so let's write that down. So we're going to have 2 pi plus 1 minus 1 over pi. The 1's go away. 2 pi over pi, so the pi's go away.
So 2.
So it equals 2. So 2 plus cosine of c equals 2. Minus the 2.
Cosine of C equals 0.
Cosine of C equals to 0.
So C
So what does C
pi.
equal?
Pi half.
We're only looking at the interval between what?
0 and pi.
0 and pi, so that would be?
Pi.
Pi half.
Yes.
Yay! Okay.
Oh, but then we have to put pi half
Are we
into the
done?
original function. Figure out.
Have we written the equation of the tangent line yet? No. So what else do we gotta do?
More work.
We gotta find the point of tangency, right?
Okay.
We know the x now,
Robertson's.
I was thinking of like.
we need the y.
I'm okay, don't worry.
And I didn't leave enough space there. It's okay.
Write a note.
I'll make it fit.
Just write a note.
So we wanna find f of pi over 2 now. So 2 times pi over 2 plus sine of pi over 2 plus 1. What's sine at pi over 2? 1 plus 1, 2, and then here the 2's cancel out, so we left with what?
Then you go from left to right.
Pi plus 2. So right here, this is pi. I'm sorry. Second thing we need is the what? Slope of the tangent line. Now we have to use who? We need the derivative?
Yeah,
Well, you already have it.
We already have it?
Yeah.
What is it?
2 plus cosine of x.
It's 2?
so small.
The slopes are supposed to be the same?
You should
So we know that the derivative has to equal to what?
2.
To 2 at that c value?
Yeah, so it is equal
Yes?
to 2.
Can I still work it out for those people that didn't see that? Oh! Yeah? F prime of pi over 2? So that's gonna be 2 plus what? Cosine of pi over 2, which gives us 0, which is just 2, right? Alright, so now can we write the equation of the tangent line? Y minus what? Pi plus 2 equals 2 times x minus pi over 2. Beautiful, that's a good problem. What would be the equation of the normal line?
1 negative 1
Y minus pi over 2 equals
negative 1
negative 1 over 2 times x minus pi over 2. What if they ask you to make approximations using the tangent line? Would they be over or under approximations in this interval? How would we determine that?
You have to see if it's concave.
We have to see if it's concave up or concave down?
Yeah.
What tells us if it's concave up or concave down?
If the first derivative is increasing or decreasing.
If the first derivative is increasing or decreasing?
Yeah, or the original function is positive or negative.
What?
I'm just kidding, that's the
But we don't know.
second
What if we
derivative.
find the second derivative? Yeah? So what's the second derivative?
Negative sine of
Negative sine.
What's the derivative of 2 cosine of x?
Negative sine of x.
Negative sine of x? And let's make a second derivative sine line here real quick.
Robert, say that.
What would be my points of inflection?
Go, Robert.
Where would this equal to 0 at? Because it's never undefined.
0.
0 and pi?
And 2.
Well, those are my endpoints, right?
0 and 2.
So we're cool. So we can pick anything in between. What do you want to pick in between 0 and pi to check?
Pi half.
Pi halves, so what's sine of pi halves?
1.
1 times the negative?
Negative.
So the second derivative is negative in this entire interval, meaning that the original function is concave what?
Yeah. So it's
Down.
an approximation.
Therefore, all the approximations that I use using this specific tangent line would be over approximations, because those tangent lines would be above. Beautiful? So they didn't ask for that, but I'm just taking it to the next level, just trying to review that stuff, okay? In case you forgot it. Awesome? Alright, so your homework is to finish the rest of the problems on there. You got about 20 minutes, so take advantage of the time, don't sit there doing anything, alright? So in brief, let's review everything that we did today.
This is IROC.
Okay? Quickly, Mean value theorem, what must be true for it to apply?
So that's where that.
Continuous on the closed interval,
However, 2 here.
differentiable on the open interval, and what's guaranteed by it?
That the.
That's some.
That I rod will equal to A rod. The derivative at some value in the interval, right, will be equal to the average rate of change. The slope of the tangent line will be the same as the slope of the secant line. Remember, it's a special case. I mean, Rolle's theorem is a special case of mean value theorem. Super easy?
Yeah.
All right, get started. Finish your homework.
TLS.